So we are back with chapter number 4. Chapter number 4 is going to be on IPv4 and IPv6 addresses. So the main three topics, they're going to be the binary numbering, decimal, and hex. Part number 2 is going to be the IPv4 addressing, and part 3 is going to be the IPv6. So for these parts, we are going to go more into depth, especially for part number 2 and part number 3. We will be talking more about IPv4 addressing, assigning IP version 4 addresses, and subnetting. This chapter is 60 slides, so I will be cutting this chapter into two parts, two videos. So each video will have 30 slides only. So part number one is gonna be on computer networking, numbering. So just this one is a discussion review. What are the two states for the electronics signals that can be? So basically we have the physically on and off, so basically 1 and 0. What does binary numbering offer a computer OS operating system? So it's usually a way to convert the signals into code that can be viewed and managed. What the advantages when we have a system admin to have binary converted to decimal or hex? To answer this question, it's usually provide a more manageable way to insert into manipulate and output from computers. So here we have the binary numbering. So the binary numbering, here we have the computers and other network devices do not understand the decimal numbers. So basically when a computer works when we have as I mentioned, the state physically on and off. That means when we have numbers 0 and 1. We see letters, we see numbers as a view on the display, but basically the computer and the networks devices work using the binary numbering 0 and 1. So numbers that are binary based 2 are difficult for humans to process. So it's easy for computers, but it's harder for us to process. So here we have 0, 1, 0, 0, 0, 0, 0, 1, and here we have multiple binary numbers in here. This usually represent a letter or a symbol. So basically we start from the right, in which this one is considered when you convert from binary to decimal. We will be talking more into the upcoming slides. Here the number in decimal basically will be 1, 2, 4, 8, 16, 32, 64, and 128. So here we have a 256 bits basically, and this one usually represents a letter or a symbol. So here we have base number 2 uses symbols 0 and 1 called binary. Base 10 uses symbols 0 to 9, it's called decimal. And base 16 uses symbols 0 and F to F, which is called hexadecimals. So basically, as I mentioned before, so here we start from the right. So here we have 1, 2, 4, 8, 16, 32, 64, and 128. If we add all of these, we have 256. Here we have the decimal values. The decimal values goes as 1, 10, 100, 1000, 10,000, and then 100,000 and so on. For hexadecimal, here we have 1, F as a whole 16, FF is 256, FFF 4096, and so on for the hex decimals. So here we have basically here we have 4, 0, 9, and 6. So here we have 1000 times 4, which here we have 4000, and then here we have a 9 and 6, so we have 4096. Now let's say we have 100101110. So you start from here. So here you have a state of 8 bits, and every 8 bits equal to 1 byte. So here we have 128. So whenever you have 1 under 128, so basically 128 times 1, you have a 0 under 64. That means we don't count anything in here. 32 is the same thing. 16, here you have times 1, which is 16. A 8, you don't have anything. A 1, 1, 0. So here we are doing this one, a converting from binary to decimal. So basically it will be 128 plus 16 plus 4 plus 2. And this one will be equal to 150 in decimal. So this number in binary equal to 150 in decimal. So we only count the ones that we have number 1, and we do not count the zeros. Now converting from decimal to binary, what do we have in here? Okay, so here 1 0, which number are we converting? Okay, so we are converting number 167. So basically you have 167. So 167 is bigger than 128. So for sure you want to put 1 under 128. You might have this one on the exam when you do Network Plus, if you would like to do it from CompTIA. So basically 167 is bigger than 128. So basically we put 1. Now what we have 1 in here and we have under 128. So 167 minus 128, how much is that? 39. So basically 39. 39 is bigger than 32. So basically we put 1 under 32. And then 39 minus 32, it's equal to 7. Now 7, so here we have 16, 8, and then we put the 7. Basically I think it will be 4, 2, 7. Okay, so it will be 1, 1, 1 in here. So it will be 1, 0, 1, 0, 0, 1, 1, 1. Because here we will end up with 7. If we end up with 8, you put just 1 in under 0. Sorry. You put 1 under 8 and then 0, 0, 0. But if we end up with 7, that means you are going to fill these, which is 4 plus 2, 6, plus 1 is 7. So that's how you convert from decimal to binary. So from 167, it will be 1, 0. I think we have it in the next slide. Yeah. So here we have 1 0 1 0 0 1 1 1. So 1 plus 2 plus 4 plus 32 plus 128, it will equal to 167. Um, so here we have a 8 bit, right? So 2 to the power 8, as I mentioned, if we add all of these, we are going to have 256. So that's why we have 2 to the power 8. That means we multiply 2 8 times. We will be having 256. So these will represent the whole letters, a upper letter, uppercase, lowercase, all the alphabet letters, including the numbers and the symbols that we have on all the keyboards, basically. So here we have 8-bit, and as I mentioned, 8 bits, it's equal to 1 byte. So if you have 2 bytes, that means 8 plus 8, which we have a 16, basically. So this in this state it's called octet. So that's why every 8 for 8-bit we have 1 byte and it's called octet. Now here we have a capital letter A. So capital letter A, it's basically a 1 here and 1 here. So we have basically the number. If you want to convert this one to decimal, it's super easy. So the upper case A, it will be 64 plus 1. Here we have 65. Now here we have the other conversion, where we have a binary to hex, hex to binary, decimal to hex, and hex to decimal. This one is not used much. It's used only from binary to hex and hex to binary, most of the cases. Now to convert to hex, it's easy. It's not that hard. So basically you have two nibbles. So here you have nibble 1, nibble 2. So this one you cut it to 1 2 4 8 and then 1 2 4 8. So basically when you have number 65, as I mentioned before, here we put 64, we put 64, we put 1 under it, and here we have 164 plus 1, which is 65. So 65 in decimal. In hex will be so you cut it to nibble 1, nibble 2. Here you have 1 2. So here you have 1248, here you have 1248, uh, and here you put 1 in here and 1 in here. So basically the number, you will be just counting the upper number for the hex. This one is a binary, basically. This is binary, and when you cut it to hex, basically you have 1 under 4 and you have 1 under a 1, so you just put 41. That's it. So 41 in hex is equal to 65 in decimal, and which is the letter A. So here we have binary to hex. What do we have here? So here is the same thing, a value 1 to 16. So here you have 2 and 4. You have 1 under them, so it's 24. That's it. That is the number that you have for hex. Now, for decimal, it's 36. Why? Because you start 1, 2, 4, 8, 16, 32, right? A 64 and 128. That's when you have a binary. So the number for binary, it looks like this. For decimal, it will be 36 because you have 32 plus 4, it's 36. And when you convert it to hex, you cut it as 1248, 1248. You have 1 under 2 and 1 under 4. So you take the 2 and you take the 4 from here and you just put them together, 24. And that is the hex number that you have for that letter or for that a number or symbol. So when it comes to IP version 4 addressing, so we know that we have multiple protocols that we use. So for example, Apple Talk was developed by Apple. The TCP/IP, the one that we are using right now as the de facto protocol, it's sponsored by the US military. So in every protocol, you need to have addresses. So you can forward the data from your local address or from your local network to the outside. So that is the whole point of having addresses, and to assign also, for example, like address to each PC locally. Okay, now how are the binary numbers represented in decimal format? So these are all the questions that we should know when it comes to IP version 4 and IP version 6. So basically, why do we need a logical address? So all these version 4 and IP version 6, all of them are a logical address. The only physical address that you have is when you connect your Ethernet, which is the MAC address. So every hardware that you have, every hardware device that you have in order to connect your Ethernet with, that is the only physical address that you have. The rest are all a logical address. So we know that the MAC address is, yes, it's unique address worldwide, but let's say you want to send a data, you want to send a packet from your PC or from your laptop or even from your phone to the outside. You should have an IP address, because when you do the end-to-end communication, you should have an address in order for the server to send it back to you. So that's why we need IP addresses. So in order to communicate with the outside world. Okay, so the IP address basically it's is separated by the dot decimal notation. So here you start from your left to right. Basically, with the IP addresses, you start from left to right. Why? Because you start with the host number, sorry, with the network number, and then you continue with these hosts. So, is this one a network IP address? Yes. Are these hosts? Are these three hosts? It depends on which class we are working with. So sometimes when you have subnet 255.0.0.0, that means you have these two at 255.0.0.0, you have all of these are as host. When you are working with a subnet mask a 225.225.0.0, that means these are the only host. We will be talking more about them in the upcoming slides, but I'm giving you an idea. It's just this one is always the network address, but these can be host or can be included with the network. So I will explain more in the upcoming slides. So here we have converting the IP addresses to binary. So basically, this one here you have um, so each one will take 8 bits, which is 1 byte. The number 10 falls under range from 1 to 126. So basically this IP address, usually it's a private IP address. You don't use it. It's only private, and you see it on your local IP in your local PC. It depends. Sometimes it's 10.2 dot something or 196 sorry 192.168. These are the private IP addresses that you see on your PC. But when you go outside the world in order to communicate with the servers outside, this IP address will not be used. This is only for your private network. This makes it as a class A address. Why? We will know later. A class A addresses use the first octet as a network number, a network number by default, and that's exactly what I told you. So in class A, the first one is described as a network number, and the rest are for host. So here we have number 10. How we are gonna represent number 10? So here you have 1, 2, 4, and 8. You put 1 under 8, and you put 1 under 2. 8 plus 2 is 10. How you are going to represent 1, you put 1 under 1 in here. How you are going to represent 2, you have here 1, 2, 4, 8. Here you put 1 under 2, and then 3, basically 2 ones under 1 and 2. That's when you convert it to binary. Okay, why does the class A address normally use only the first octet as a network number? Because we have something called subnet mask. That's why it takes the first one as a network number only. So here we have math, and I will be including a document on Canvas on better understanding with IP addresses and subnet mask. So basically, when you have a class A, and this is very important to memorize as well. So you can memorize it, or if you understand it, it's even better. So basically, here you have 10, 1, 2, 3. This one, when you have a class A, you have a subnet mask in decimal of 255. And then here, zeros. So you can have, I think, I don't know, thousand or millions of hosts that you can have in here. So here we have the subnet mask. So once you have 255, this subnet mask, it will be one, only ones. So the ones are for network bits, and the zeros are only for host bits. Again, the ones are always for the network bits, and the zeros are always for the host bits. You cannot mix them up. You cannot have 0 1 1 1 1 1. This is not network. And you cannot have 1 0 0 0 0 0. These are not host bits, so this is not allowed. So you have, it's either all of them 1 or all of them 0. So all of them 0 are for the host bits, and all of them 1 are for the network bits. So here you have a subnet mask of 255 because we are working with class AA. Yes, as I mentioned, we cannot mix them. We cannot have zeros and ones together. As you can see here, for the subnet mask, you have 1 1 1 1 1 1 1 1. This is for the network bits, and here for all the host. You cannot have this example is not a valid subnet mask because here you combined zeros and ones in here. What do we have here? So we have IPv4 subnet mask are used to, okay, so here to reveal the network number for the given host, of course, to design network with a optimal sizing, and to optimize the network performance via routers. So here we have 192.168.2 and 0. So here we know that this is class C. Yes, this is class C. So here you have 192.168.2.0. I know class C because you have 255 in here. So when you have 3 of these, you have class C. When you have 2 of these, you have class B. And when you have only one of 255, you have class A. So basically, when we have 255 in here, the only host that we are gonna have is we will be a total of addresses 256. Now, when you go to more advanced network, yes, we have 256, but the first one and the last one are not used. Why? Because here, when you have 192.168.2.1, usually the number, you don't use it as a host, you use it for the gateway or for the router that you have at home. So basically, when you go home, you put your IP address, you have 192.168.2.0. So your router, you can actually go to the web browser and you put 198.168.2.1. It will go to your carrier provider, which is Xfinity or AT&T. Now for the last number is used for broadcasting. So let's say you have a huge network, you are assigning 254 PCs in a company, so you want to send a broadcast message to all of them, so you use the IP address of 192.168.2.256. That is used for broadcasting, and 192.168.2.1 is used for your router or your gateway. Exactly. As I mentioned here, benefits since it reduces the amount of broadcast traffic inside this network. So basically, you have 256 in here. The last one is broadcast, and the first one is for your router. This table is very important. Here you have class A, B, C, D, and E. Class A basically from 1 to 128, B 128 to 191, C 192 to 223. So here you have a very large organization here. Maybe you can have for a city. You can have a certain city that using an internet or a network. um, you can have a class A here network. Class B medium, class C is small. A D and E, they usually are not used. It's usually for multicasting and experimental IP addresses. So we use these when we do more research and when we do multicasting. Multicasting, I will be explaining it later. Um, so here class A, we have 10, 56, 20, 33. Here you have 255, and these can be a whole a host. So basically 56, let's say you have a huge building, right? So a 56 is floor number 1, 57 is floor number 2, a 58 floor number 3, a floor number 3, and then here you can have multiple hosts connecting. So here you have 57, let's say for floor number 3, a 20 for room, I don't know, 120, and you can have up to 254 devices connected to that IP address. So it's a huge number. So here it's different way of looking at it. So the network information is 10 because here we have class A, and the host information is these three numbers 56, 20, and 33. When it comes to class B, as I mentioned, you have 255, 255. That means the first two are network information, 172 and 31. The host information will be 38 and 81. Class C, you have 192, 168.42. This is just a small network that you can have. So these are for the network information. These cannot be changed or touched. The only thing that you will be having is with these hosts. So this was basically host number 7 here. And the host number information is 7. Here we have class A, you have from 10, that's why I told you 10.1.2.3 is usually a private IP address. A class B here, private IP networks. So you have class A, B, and C. You have 172.16.0.0, a 192.168.0.0, and here you have basically an example when you have a default submask, a subnet mask for them. We have special address ranges as well. We have for I think a automatic private IP addresses, AP, IPA, I believe, and loopback. So basically the loopback in here, yeah, special address ranges. So here we have a loopback. Every PC has its own address when it comes to loopback, and the address is usually the same. You can have 127.0.0.16 and 15 and 14, but the default one on your PC is 127.0.0 and 1. AP IPA, here we have a class B. It works on 169.254 0 and 0. API APIPA is usually when you have a self when they sign when the PC sign an address by itself. So self sign IP addresses basically. Yeah, it's automatic private IP addresses. Automatic private IP addresses is short for APIPA. So here we have the type of addresses. We have addresses to identify three categories. So basically, unicast, we have unicast, broadcast, and multicast. That's why I told you the last IP address for the last number of the IP address that you have, it's usually used for broadcast. So here we have unicast is basically one-to-one data session. It will not include any a device. It's only from one to one. A broadcast is one to all, so you can send a broadcast message to everybody. A multicast is one to many. Basically, you assign to which PC or laptop you want to send or which device. So here basically you have a unicast. It travels. So here we have a server. Destination address is 10.1.1.1, a 10.1.1.2. So here basically from 1 to 1. So you have a server, receivers. These are three receivers. We have 1, 2, and 3. And each one it has its own destination address. So this is basically a unicast only from 1 to 1. And these are two separate packets. That's why we have them two separate, a red and green, because only this one for this and this one for this. So it's only one to one sending messages. Now here broadcast is you have one message. Here you have one message that basically use the last address that you have in here to send to the receivers. So this all the receivers will receive this data basically from one message or from one packet only. Multicast. So here you have a destination 239123. So basically, this one you should assign multicast group before you send this one, or this one has to have a different configuration when it comes to multicasting. So it can know to which address should send or to which a group that it should send. So a group has an address 239.123. So basically this one, the destination is going to receiver A1 and receiver 2. It doesn't go to receiver 3 because it's not part of the multicast group. So you need to assign a multicast group, which in here we have a case of the IP address 239.1.2.3. This IP address looks weird. Why? Because it's class C, I believe, if I'm not mistaken. No, it was, sorry, class B. In a class D. Class D it's for multicasting. So these are not usually used. As I mentioned, we use A, B, C, but these are the weird IP addresses that use for multicast and experimental research and so on. So this one, it falls under class D when we have a multicasting. That's why you have a 239.123. So I will